On my background, I grew up in northeast Nebraska, and using corn stalks it's part of my legacy. It's my grandfathers had beef cattle that they ran on corn stalks. My father had beef cattle, two of them, actually three brothers. One is sort of a hobby farmer, but they run cattle on corn stalks. Brother-in-law does, etc. Some get by without any tillage, and others think, well, that's their excuse for tilling, or they justify their tillage because the cows are out there and they think there's some trampling, etc., compaction. So anyway, let me move on. So a little bit on the implications for soil and crop productivity. And much of what I'll be speaking about is captured in this NEB guide, Harvesting Crop Residues. And we did update it just in 2012, so it's quite current, and I think a very good information source on this. But I'll speak a bit about, first of all, what's the value of nutrients removed? How do you determine that? And then some on the effects on erosion, soil properties, crop yield, and a little bit on cover crops, double cropping for forage production, and manure application relative to this. And then it's one other topic I'll address briefly. The table 1 in the NEB guide addresses nutrient concentrations in the stover. So we have our NPK sulfur in the left-hand column, then the concentration and the residues, an estimate of pounds per ton, and then there's a worksheet where you can put in the current cost of the nutrients, fertilizer nutrient cost. And these are values from when we revised it in 2012. It says May 2012. And then you can go on to calculate how much value is in a ton just due to the nutrients. So a big question is, how do we estimate how much residue we have out there? Well, a simple guideline is given in the NEB guide, where we say you have about 1 ton for every 40 bushel of corn produced, and 1 ton for every 30 bushel of soybean, and 1 ton for every 20 bushel of wheat. So again, this is just another table showing how much we have on average, and it's quite variable, but on average in pounds per ton. Potassium is the one that's most variable, because after the plant tissue freezes and the cells disrupt, the potassium is easily leached out when you have a rainfall event. So we can find a lot of variation in that, and very often it's not so much as 34 pounds per ton. Effects on soil erosion. This, I think, has to be our most important consideration when we think about removing crop residues. This figure is a bit complex, and we'll step our way through it. It was generated using the NRCS tool called Russell 2, revised Universal Soil Loss Equation version 2. And what we have here are estimates for 3 different counties in a transect across the state, so Gage, Sherman, and Chase County. And we have it for each of these 3 slope classes, 2, 5, and 10% slope. On this axis, then, we have how much residue we need to prevent our erosion from being more than 5 tons per acre. Now, 5 tons per acre, it's not too bad. It's bad, but it's not too bad. We would like it to be well under this, but this is sort of a guideline that we use. We certainly don't want it to exceed that. And then here our different colors are for different tillage and terrace systems. So black is for no-till without terraces, green is for no-till with terraces, and then we have red and gray for disc with and without terraces. What we see for some situations, we'll just concentrate here on Chase County, with 10% slope, if we're doing tillage, we don't want to remove anything, because we need at least 5 tons of residue out there every year to keep our erosion below 5 tons. If we're doing no-till, and especially no-till with terraces, then there would be opportunity to remove some. But we still want to leave like 2.5 tons here to give us adequate protection. If it's even with 5% slope, if we're doing disc tillage and have no terraces on it, we probably don't want to remove any crop residues if we want to prevent water erosion. With terraces, we could maybe take off some, but still leave an average of 3 tons. It doesn't have to be to leave 3 tons every year, although that would be sort of the ideal, but sometimes you might leave only 2 tons, and other years you don't take any off, but it averages out. If we look at no-till, and especially no-till with terraces, then even, as we said, even with 10% slope, we can take some off. And we can take quite a lot off when we have low slope conditions. So in summary, to avoid excessive water erosion, generally we do not want to harvest if we have more than 10% slope. Now grazing might be is an exception to this. Here I'm really talking about going out and mechanically harvesting and baling it, etc. With grazing, we still leave most of it out there, and the cow is giving you some organic material back, so it's not so bad. If it's 5% slope, generally we do not want to harvest unless it's no-till. And we want to maintain an average of somewhere around 2 to 3 tons, even with the best conditions. And we'll see that fits with some of our other targets that we might want to have. Wind erosion is another concern, and more so in western Nebraska than further east, but even further east can be a concern. So here we have estimates for North Platte, Cindy, and Scotts Bluff. We have it for highly erodible soil, medium and low erodible soil, erodibility soil for each of those locations. And again, we have how much crop residue do we want to keep out there to keep our erosion less than 5 tons per acre. And again, 5 tons is a bad loss, but we certainly don't want it to go above that. And let's focus on the North Platte area since it's closest to us. Here we have 3 different tillage or cropping systems. The red is no-till continuous corn. The gray is no-till wheat-corn rotation, or at least having wheat in a rotation once in every 2 or 3 years. Disc no-till, or disc continuous corn, and then disc wheat corn rotation. So we see with having wheat in a rotation, it does help us on erodibility, wind erosion, protecting against wind erosion. So even with high wind erosion, if we have wheat in a rotation, and if we're going no-till, we can remove. And even here with continuous corn, no-till, we can remove. We leave an average of about 2.5 tons per acre. You have 200 bushel, think back to what I said before, 1 ton per 40 bushel. So 200 bushel corn gives you about 5 tons of crop residue. If it's continuous corn, it means on average, here, even with highly erodible soil, if you're doing no-till, you can take about half of it every year. And then we have our tillage situations. And generally, if we're doing tillage, it's suggesting to us that we should not remove any. Maybe a little bit if we have wheat in the rotation. So to summarize on this, to avoid excessive wind erosion, we want no or infrequent grazing maybe, or light grazing, for tilled highly erodible soils. We want little or no harvest with tilled medium erodibility soils in the panhandle. We have much more opportunity for removal if we're going no-till, and more opportunity if we have wheat in the rotation. This is a photo from the other year from a field quite near here, and you see how clean they managed to get it. It looks like they cut it off and raked it up and baled it, right? And just looking at this soil, it looks like a silt loam soil, looks like something to be very subject to wind erosion or even water erosion. And so this is a situation we certainly don't want for ourselves if we're thinking long-term about our farming operation, our crop production operation. Much nicer is this one, where when they harvested, they took precautions to leave quite a bit of stock standing. When they raked it, they used a wheel rake and were very careful about the down pressure on it. So they didn't get everything, but they got a lot, as we see from the bales. And not only that, they aerial sowed winter rye into it in around 15th of August. And we see quite a bit of green here. This is in November. This person was concerned about wind erosion. It's in a Platte Valley, a bit sandy soil, and he's got a 10,000 head feeding operation. He needed the stocks, but he's managing to minimize the potential for wind erosion. And that's why he's investing like $25 per acre to have the rye cover crop out there to give that extra protection. A little bit on soil properties. There's a lot of work being done on this, and a lot of it looking at the effects on soil organic matter. This figure just shows some of the different, sort of, let's say, a consortium of ARS, Agricultural Research Service activities across the country. And we do have very good involvement in Nebraska in this, with much of the work, but not all of it at the RDC. In thinking about soil organic matter, the most important organic material that we supply is what we have underground. That's most effectively converted to longer-term soil organic matter. That's what's most effective in giving us aggregate stability and this sort of thing. The above-ground biomass is much less efficiently used. We'll be looking at the results from this of two studies that are done in Nebraska, one with a rain-fed, rather marginal soil, and another with an irrigated, very good soil. With the rain-fed marginal soil, the organic matter is about 2%. It's a sloping land that was once had quite a lot of erosion, so topsoil in the past was lost. This, well, it's been going about 14 years, but the data I have is for the first 12 years. What they observed after 12 years, that there was an increase in soil organic matter, both with stover removal and without. They were taking about 50% of the stover off with this rain-fed situation. Now with no removal, the gain was a little bit more, about 1.42 tons per acre per year in soil organic matter, compared to 1.25. So it tells us that with some soils, even with harvest, we can continue to improve organic matter. But these are soils that are a bit low for some historical reason, such as erosion in this case. And I have this figure here, not to explain it, but just to point out, if you want more detailed information on this, it is available. So this was an interesting observation, a relatively low yielding site, and we'll get to the yields in a bit, but they are seeing this increase in soil organic carbon, or organic matter. And it's going deep. They're seeing increases down to 4 feet. So this change is for that 4-foot profile. It's not just in the plow layer or the top 4 inches, but some of it is down deep. Then they have the irrigated site, and that has greater than 3% organic matter. It's nice level land, silt loam, very nice site. There they're comparing this to no-till, and they're removing, they have 0, 40, and 80% of the removal, or at least that's their target, to remove this much. Now what they've seen there is a small decrease in soil organic carbon over the 10 years, over a 10-year period, for all the treatments except for the no-till where they took nothing off. But no-till with some removal, they saw a small decrease, and with tillage, whether they removed or not, there was a small decrease. Not a big decrease, but it's like this soil is sort of at a plateau as far as soil organic matter goes. It's very difficult with current management conditions to push it higher. We can maintain it maybe by leaving all the residue out there or no-till, but we can't push it higher. So that brings me to this topic, soil organic matter plateaus. As more and more research is done on this, we do see evidence of this, that there is a level beyond which to increase the soil organic matter is very difficult, very slow, and maybe doesn't happen. In some of the soils with putting all the residue back, as we saw in the previous slide, we have evidence that we're continuing to lose organic matter. Some of this is very old organic matter. It's from the prairie days. It's 150 years old, but it's slowly being leaking away from us. And with our annual cropping systems, we just cannot maintain it. So we have to be realistic about what we can expect on organic matter. And that point I made before, it's the below ground biomass that is especially important to soil organic matter. The top growth, yes, it can contribute by leaving some out there, help us to maintain it, but what's most efficiently converted to organic matter is the below ground biomass, and also for soil physical properties, the soil aggregation. So, but it is something we have to be concerned about, is the organic matter. And we know it's important for soil chemical properties, cation exchange capacity, supply of nutrients, etc. It's important for soil physical properties, such as to avoid crusting, have good water infiltration, good water holding capacity, and for microbial properties. But we've suggested in the NEB guide, if we leave an average of 2 tons or more, average per year, not necessarily every year, but average per year, it appears to be enough to maintain our soil organic matter productivity. We're not losing out. Our soil is not degrading because of it. Now here we have some results, and actually Tim Shaver was involved in this. These are results from Colorado, a dryland situation, so not much residue produced in any case. And they continued this work for 12 years. And here we have the cumulative amount of residue in pounds that was left out there over the 12 years. And the 2 ton per acre per year level would be right here. And here we look at the effects on total aggregation. Well, one way to look at this is just a linear effect, and the straight line. And it, fits pretty well. But if we look more closely at this, we see that there's a big change in water-stable aggregates by just leaving the small amount extra on, maybe 1,000 pounds more per year. And we continue to see an increase as we leave a bit more on. But here it appears that we've met a plateau, or reached a level where we're not gaining anymore. Now, it would be nice to have more data going further out on this with higher levels remaining and more observations. But a way to capture this is something like this with a curvilinear response, where we have the very big increase improvement in soil aggregation by at least leaving some out there, a bit more by leaving a bit more, but eventually we reach this plateau where we're really not gaining anymore by leaving more out there. And again, this is our 2 ton per acre yield. So it's supporting what we have in the NEB guide. And some of this other information is supporting what we have in the NEB guide. Soil water is a big one for you, more so than in eastern Nebraska where we get more rainfall. Even though there it's important too. But the residue can help to reduce evaporation, to trap snow, and to reduce runoff and increase infiltration. How much reduction in crop available water with residue removal? Well, different estimates of 0 to 5 inches depending on the situation. In eastern Nebraska, often we have enough rainfall in the winter, precipitation throughout the winter and spring, that our soil profile is fully recharged. And so if there is some water loss, it's not an issue. It's still recharged. It's all percolating down below the root zone, the excess. Here it's less likely to happen, so it is more of an issue for you, especially with dryland production. This is something that we just started to investigate last year, but does stover removal affect the amount of nitrogen that needs to be applied? Now, there are proponents in Iowa saying that if you do a stover harvest, you can reduce your end rate to corn by 45 pounds per acre. Similar as if we, to the credit that we give with soybeans. Now, I don't know what they base it on. But part of it is the principle that by removing the crop residue, we have less tie-up of nitrogen. You know, with the crop residue is low in nitrogen, so for the microbes to work on it, they have to find nitrogen from somewhere else. If we put on fertilizer nitrogen, some of that nitrogen is immobilized as microbes use it to begin breaking down these crop residues. And so their argument is, well, we're taking away a lot of this crop residue, so we have less immobilization. More solid evidence is from Minnesota, where there they estimated you can reduce your nitrogen rate by about 22 pounds per acre by removing some of the stover. But we're looking at it, and we just started last year with 3 sites in eastern Nebraska, and we're comparing no removal with 75% removed. Then we have 6 end rates with each of these to determine the response function. And so that's our objective, is to determine, is the nitrogen response curve different for removal versus no removal? And we haven't looked at many results, but this is from one of the sites. The upper line, the orange line, is where we had 75% removed, and the lower is where we had no removal. And there's a little bit of difference in the shape here, but it's too shaky evidence at this point yet to draw any conclusion. What we do see is the higher yield with the removal, and that's something that's very common throughout the Corn Belt, at least. Whether that's true here or not, I'm not sure, but certainly for eastern Nebraska and further east throughout the Corn Belt, it's a very common observation. So we spoke a bit there about crop yields, but let's look at that a bit more. These results this is the yield results from that study I mentioned before, the dryland study with the lower, less productive soil at Meade, Nebraska, where ARS is working. These are the mean yields for 10 years, I guess, 2001 to 2010. And they had their different end rates, and they had 2 levels of stover removal, 0 removed, 54%. So we definitely see the end rate, a good response to the 120 as compared to the 60 pound rate, and not much or no response beyond that by going to 180 pounds. If we look at the effect of the stover removal, here by removing stover, we had quite a yield loss. Well, on average 6 bushel lost over the 10 years. And that's probably because it's short on nitrogen. We're taking away nitrogen in the long term, and although you can have that short-term effect of needing less nitrogen the following year, over time we expect it to accumulate. So it could be that. Here, however, we do not see any effect of stover removal on the yield, these dryland yields. Or here also with the higher end rate, actually, there it's starting to give us a bit of a yield increase. So that's from that dryland rain-fed situation, relatively low yielding situation. And again, I showed this figure because there is much more detailed information on it if anyone's interested. These are results from that irrigated site. And the yield results are for 2 years, 2009 to 2010. But at that point, the experiment had been in place from 9 to 10 years. So there's quite a bit of history going into it. But unlike the other case where I presented the yield averaged over all the years, just as it was from the later 2 years. So we have disc and no-till and 3 levels of stover removal. First we can look at the tillage. And generally we see higher yields with tillage under that situation, whether stover is removed or not. And then we look at the effect of the stover. Here with disking, we see that by removing 76% of the stover on average, and even less, we're getting the yield increase. And also with no-till, we're seeing the yield increase by taking away from some stover. So results that are generally consistent with what we're seeing farther east throughout the Corn Belt. And this is over, like I say, after 10 years. What about grazing stocks, and especially for no-till? We need to do tillage after grazing stocks to be able to maintain our productivity. This is also work from the ARDC, and it's after 17 years, the average of 17 years. And so what we have here, it's corn-soybean rotation, and it's the corn stalks that were grazed. So what effect did it have on the soybean yield the following season? There was spring grazed, there was fall grazed, and there was ungrazed. And these are the average yields. Not very much difference, but certainly no yield loss due to grazing or compaction or whatever it might be. The spring grazing was intended to create a worst case scenario. And so they had their animals out there right up until the day of planting or the day before. The worst case scenario. So often a bit wet out there and more compaction than you would like to see, but it did not result in a loss of soybean yield. The corn yields here are for that following year then, after the soybeans. The soybeans weren't grazed, but we see also no effect really on the corn yields. So this looks very safe for us. We can graze stover and still do no-till. And especially if we limit our grazing to the fall or take the animals off by the end of February or something like this. And again, this was intended to create that worst case scenario. The grazing was in the spring. We can compensate for some of that stover removal, of course, by manure use. And that's something to keep in mind. And people are very aware of this. I think cattle feeders typically put a lot of their manure where they cut silage, for instance. They know it's important to get something back. Cover crops, or planting a second crop, maybe for forage production, can also be valuable. And the photo again is the one I showed before. I really think there's a lot of value in this. It should be primarily aimed at reducing wind and water erosion. And there might be some small contribution to soil organic matter and other properties, but I don't expect much. Generally for these situations, we don't get that much cover crop growth. And we have to be realistic in our expectations. But in thinking about cover crops, we do need to be thinking of our objective. This producer had his objective well defined. He wanted to protect against wind erosion. He had neighbors with cows that wanted to graze it. He said, no, I don't want your cows on there. That's not why I sowed it. So he was sticking to it. He defined his objective and he stayed with it. And then you have to think about your niche. How can you fit the cover crops in? And he went with aerial sowing. And in 2012, it was his first year to do it, but he went whole hog. He did, 750,000 acres. All of it winter rye. And he did one irrigation after that. And he said, I bet I could have improved that by doing 2 1/2-inch irrigations. So that's what he's gone to. And I haven't seen his field this year, but I understand he's had very good success. So it's quite easy for him to do. And he's got that cover out there to give him that protection against the wind erosion that he was concerned about. Double cropping for forage production. This is something I'm very interested in. And we have some nice niches there. And one is with brassica, things like turnips and radishes sown into seed corn. So what some producers are doing, seed corn producers, is when they take out their male rows, and generally early August, they are broadcasting turnip seed in, all in one operation, just have a small seeder mounted on the back. And they harvest early, late August, early September, they're harvesting. So it gives a good time for the crop to grow. They put their steers on in November to February, or cows. But they find that it's really too rich for cows. The cows get fatter than they want to see. But the steers can use that high quality grazing very efficiently. And figuring that we have like 170,000 acres of seed corn production in the state, it looks like it could support around 300,000 steer months of feeding. And they claim they get their 2.7 pounds a gain out there, which is quite good considering how little they invest. Another obvious opportunity is drill seeding of oats or winter rye into your fields after cutting silage, taking your corn silage off. It also gives you the protection against erosion, of course, but it does create that opportunity for fall grazing or for providing good calving ground for your cows' calves in the spring, as well as high quality grazing. Some things that I think we need to investigate more on this is what are really the effects on animal performance with some of these double cropping opportunities? What's the effect on yield of the following crop? What's the potential for reducing leaching of nitrate and depletion of water? This diagram I just include, it's something I hoped that we would get work done on last year, but for different whatever reasons, I don't know yet, we did get it done. But the idea was to look at it with and without grazing the cover crops, and there's a reason for the design as it is. And this is a fenced off area, so we would have it with and without grazing. For rain-fed wheat systems, there's been some very interesting work which Umberto was involved in from Garden City, Kansas, and John Homan, his colleague at that time. Very interesting work where they found that either with a cover crop or a hay crop terminated by the end of May, they could get some nice production and it did not hurt their wheat yields. Now the situation in Garden City is a bit different than here in that they get relatively more rainfall in June, July, and August than here, I think. And so they had those months to restore the soil water more so than we might have here. But still, it's some information that you might want to take a look at some point. What about BT versus non-BT? Now, I realize almost everything these days is BT and it's no longer an issue. But 10 years ago, we were concerned, well, the BT, the cows don't like it, they don't do well on it, etc. And so David Tarkelson, who was at West Central at that time, did some work on this and studied it very well. And the question is, do we have lower decomposition with the BT varieties as compared to non-BT? Do we have less digestibility? And what he found is, as we might guess, is that, of course, the plant part makes a difference. The leaves decompose more quickly than the stalks, and the stalks more quickly than the cobs. And with the leaves, he found that 80% of the nitrogen was released after 2 years. Whereas with the cobs and stalks, after 2 years, there wasn't much released yet. It was still tied up in the organic material. And he found that there was no difference in the rates of decomposition for BT versus non-BT. And so it's all about microbes in that case, and it's all about microbes in the rumen of your beef cattle as to whether they can digest it. So I think the results do imply that BT and non-BT probably have quite similar ruminant digestibility. So to recap on some of this, the crop residue, our greatest concern should be about erosion control. Under some situations, we can get increase in organic matter whether we remove the stover or not, as we saw from the longer-term study at the ARDC. In other cases, whether we remove or not, we're losing. If our organic matter is, say, above that plateau where it's likely to stabilize for those management conditions, we're likely to be losing, and that we saw with the high yield situation at the RDC. In the NEB guide, we suggest that leaving on average 2 tons per year is generally adequate to maintain soil productivity if erosion is controlled. Generally, I'm finding the results support this. Water loss is an important consideration. In the Corn Belt, at least, and I don't know if it holds true here, corn yield generally increases if we remove some crop residue. And we saw that small soybean yield increase with grazing of the stalks. Cover crops and double cropping for forage production offer opportunities to compensate for some of that stover removal, at least to reduce erosion. Whether we can get some other benefits from it, that's still very questionable. Thank you. Any questions? If there's time.
You said about planting whenever